I thought that said mom.
All right. So, yeah. All right. So, last time we saw how factoring could be useful in solving polynomials, right? Because these polynomials that are nonlinear can't be solved using linear techniques. So we had to solve them using a different technique. And the different technique that we used to solve these nonlinear polynomials, fancy, was factoring. And what allowed factors to help us solve nonlinear polynomials was the zero factor property. And that said this, that if you can create factors, like A times B, and set those factors equal to 0, then what can happen is you can set each individual factor equal to 0. Because if two numbers multiply, I should probably rephrase that, if two values multiply to give you 0, then either the first value is 0 or the second value is 0. Maybe I can say that even a little bit better. If two factors multiply to give you 0, then either the first factor is 0 or the second factor is 0. And it's not limited to two factors. I mean, you can have as many factors as you'd like. Likewise, if you have more than two factors, like if you have three factors, then either A is 0, B is 0, or Z is 0. C is 0. Man. Okay? If factors multiply to give you 0, then one of the factors has to be 0. That was great. However, today what we're going to see is that there's a lot of cases where you have a polynomial that's not linear. If it's not linear, then that means it can't be solved using linear techniques. If you're kind of confused about what I mean by linear techniques, those are usually opposite operations, like undoing addition with subtraction and undoing multiplication with division, those kind of basic opposite operation techniques. So if we're to solve things that are non-linear, we could do factoring, right? Factoring works well. It worked really good last time. But there's a lot of non-linear polynomials that don't factor, and that's a big problem. If they don't factor, then obviously we can't use the zero factor property. So if they don't factor, then how do we solve them, or do we give up? But we're not quitters, so we got to find a way to solve these nonlinear polynomials. What I want you to do is, for the next, hopefully I can get this done in about 10 minutes or so. For the next 10, 15 minutes, don't feel obligated to take notes. Okay? I want you to just kind of digest it. This is more for culture purposes than anything else. This is not to impart any knowledge that you're going to have to reproduce to you. Well, in the next 10 minutes, what I want to do is I want to show you how we handle things that don't factor. Okay? I want to show you how we handle them, and then I'm going to give you kind of a more general statement after that. But for the next 10 minutes, I just want you to kind of digest it. Okay? You don't have to write it. You're not going to be responsible for any of this material in the next 10, 15 minutes, and then I'll tell you when you need to kind of start perking back up and get the pen and paper going. Okay? To get things going, I want you to consider something that's nonlinear but very, very basic. Okay? That guy. He's nonlinear, right? What makes this nonlinear? The squared, right? X squared. And we found out last time that the opposite of a square is a square root. Remember how we dealt with square roots last time as well. So this basic case, what I could do to get x by itself is I could use opposite operations. I could square root both sides, because the opposite of a square is a square root. Remember that fundamental property that a square and a square root undo each other, and leaves me with just the basic x. And then we've got to see if that square root simplifies, and we did that with the factor tree, and we learned that this this factor tree actually ends up being, what is that, 2 squared times 2. So the square root of 8 actually ends up being 2 square root of 2, right? Square root of 8 comes up a lot. So if you just kind of want to put that in a mental file, square root of 8 is 2 square root of 2. But nonetheless. So we found out the x value is 2 square root of 2. Look what I did. I solved this without factoring. This was a polynomial. It was a monomial, but it was a polynomial equation that I solved without factoring. There was no fancy factorization. There was no GCF, there was no quadratic trinomial, and it wasn't a difference of squares. I solved it, right? Likewise, I can solve this guy. Hey, by the way, and I solved it without it equaling 0. I didn't have to use the zero factor property either because I didn't factor it. How about this guy? I can solve him as well. You know what I do is, on that left-hand side, the entire quantity is squared, right? So guess what? If I'm trying to get rid of that square, you know what I'm going to do?
The entire thing with the square root.
Square root. To get rid of that square, right? Square root both sides. Why am I square rooting? To get rid of the squares. Essentially getting rid of the parentheses. Well done. Okay, that does the trick. The square root undoes the square. And I know this isn't fancy terminology, so I'm going to try to cover my tracks there. Essentially, the square root undoes the square, leaving me with x plus 2 equals the square root of 5. And now look what we got on the x. It's not a nonlinear polynomial anymore. It's a basic little linear equation. I can solve that. One more step. Subtract 2. Well done, Mike. So we subtract 2, and when you subtract 2, you can't subtract 2 on that square root. So x is the square root of 5 minus 2. It's not the square root of 3. Okay, the square roots can only be subtracted from other square roots that have the same sign. All right, so we solved this. We solved this without factoring, and it didn't equal 0. But the key characteristic to this was the fact that the left-hand side was a square, right? It was a quantity squared. So one more example. That. You know, usually what we do is we try to get this equal to 0. But you know what? I think that I can solve this without getting it equal to 0. Watch. The reason why I know that this thing does not need to equal 0 is because that left-hand side factors a certain way. Can you factor that left-hand side for me?
X.
X plus 1. X plus 1. That equals 9. The reason why I didn't get it that equal to 0 is because look what happens on the left-hand side. X plus 1 times x plus 1 is x plus 1 squared. That square is creeping up over and over and over. Now guess how I solve this? Square root both sides. Square root both sides. I didn't have to get this equal to 0. All I had to do was make sure that the left-hand side came out to be something times itself. Because if it was something times itself, then it's something squared, right? X plus 1, square root cancels the square, equals the square root of 9. That comes out to be pretty? 3. And then that comes out to be x is 2. That could be solved without getting it equal to 0, without using the zero factor property, because it came out to be something times itself, something squared, which can be undone with a square root. This is good. However, not all quadratics come out to be something times themselves, do they? So that's why I'm going to beat the polynomial into submission. I'm going to make it factor the way I want it to factor. How do I want it to factor? I want it to factor into something times itself. That way I have that something squared, so I can undo it with the square root. Take a look at this. Let's take a look at a nice quadratic trinomial nice quadratic trinomial. He even behaves himself and it's equal to 0. Okay, that's nice. But the problem is that that quadratic trinomial does not factor, does it? There's no GCF. That quadratic trinomial does not factor into a binomial times a binomial because there's no value that multiplies to give us 1 at the same time adds to give us 4. This doesn't factor. It's definitely not a difference of squares, right? So this quadratic trinomial that doesn't factor, how can we use the zero factor property if it doesn't equal 0? Well, I can't. But what I can do is I can use the technique that I showed you over here if I can somehow manipulate this guy to get it to be something that factors times itself. In other words, getting it to be something squared. Here's how you do it. You do the same thing every time. The reason why this won't factor, it's because of this guy. He's the problem. If he's the problem, I want to move him out. How should I move that 1 to the other side? Subtract it, right? He's the problem. I'm moving that 1 to the other side. Now there's an opening here. Okay, all right. If I move to the other side, subtract 1. 0 minus 1 is minus 1. Okay, good. Now, who should replace that 1 that didn't get the job done? It did not factor. I need to replace him with something that's going to force that left-hand side to factor times itself. There's a technique to figure out who does that. The technique is this. The first thing you do is you look at the b value and you take half of it. First you take half of b. So when I say b, I mean the second value. Take half of this value. See, divided by 2. 4 divided by 2 is 2. And then after you take half of it, you take this and you square it. You take half of the second value, sometimes that second value is called b, a, b, c. Take half of the b value and square it. Half of 2 is 4. Try again. Half of 4 is 2. And then square it. 4. That should be the new replacement. You take half of that middle term and square it. Let's see if it factors the way I wanted it to. Remember, it doesn't equal 0 because it didn't factor. I'm forcing it to factor. X and x. 2 and 2, does that work? 2 plus 2. Yeah? Good. Even better, the left-hand side is now
equal to the right-hand.
A square. That's right. So you get it. You get the idea that it has to be a square. Hey, by the way, I better do something here before I forget. And you know what? I was so excited about how he came up with the 4. When I add 4 to an equation, I better watch myself, because when you take an equation and you start randomly adding stuff to it, you better be careful. Because when you add 4, that's fine. Well, you know what it does to an equation, don't you? It makes it unbalanced. So I better add 4 to the other side to balance that out. I can't just randomly slop in a 4. If I add 4, go for it as long as I do it to the other side. X plus 2 times x plus 2 is x plus 2 squared. Now I'm back to the kind of examples I was before. You see, I took any sort of polynomial that didn't factor, and I forced it to factor the way I wanted it to. How did I force it to factor? I moved that third term to the side. I took half of b and I squared it. Now I can finish this out. I can square root both sides. Square root of 3 comes out to be nasty. You can try to factor tree. It's not going to do you any good. Now what? One more thing. Subtract 2. That tells me what the x value is. It's the square root of 3 minus 2. We'll see later there's actually the same thing. That's the negative version of the square root, but we'll get there in just a second. Okay? All right. Well, this is, this looks fun and it's entertaining and all, but it doesn't look like it's the most exciting thing to do for every problem, right? And it seems like there was some sort of sequence that you could follow that will solve every quadratic trinomial. It follows the same basic pattern, okay? So why don't we do this? Why don't we do this process to a quadratic trinomial that doesn't have specific numbers in here, why don't we do it to a quadratic trinomial that has just generic numbers? And how we generalize numbers is usually with letters, right? Why don't we do it with something that's general? That way we'll never have to do this. We'll never have to do it because we'll do it once for the general case, and then once we do it once for the general case, that general case will take care of all the other specific cases that we'll ever want to do. That's what, or we could do this every time. I don't think we want to do that every time, right? We'll do it once, and when we do it once for the general case, it will cover every specific case. That's what's going to happen. So, if we're going to have to do this, if we're going to have to redeem the quadratic trinomial race, we're going to have to generalize this quadratic trinomial. I didn't use specific numbers. I just used A, B, and C for the numbers. And then what I'm going to do is I'm going to do this routine, and that way I'll never have to do this process again. This process is called completing the square. You won't have to ever complete the square again because I'll do it in the general case. Okay? This guy obviously doesn't factor. Do you remember from the previous example, the reason why this doesn't factor is because of who? A, B, or C?
C.
C. How did we move him?
Subtract it.
Subtract him. That's what we're going to do. We're going to subtract it over. So 0 minus C is still minus C. Okay? Now what? Well, now this thing needs a replacement. And we get the replacement by doing the same thing every time. You take half of that middle term and square it. So look at my middle term. The number in front of x is b. So I take half of b and I square it. That gives me square the top. That's b squared over square the bottom. 4, right? 4. B squared over 4 is going to be the appropriate replacement. Remember, you can't just go slopping in b squared plus 4s. You have to compensate. If you add b squared plus 4 on one side, you got to add b squared plus 4 to the other side. Add b squared divided by 4. This is good. Now that left-hand side of the equal sign should factor. It should factor. Okay? Well, the problem is that when I look at that first term, I'm not sure how A factors. Right? I'm not sure how A breaks down. So maybe I can get rid of A somehow. You know what? I can get rid of A, not by subtracting it, but A is multiplying. How can I get rid of multiplication? Division. Let's divide everything by A. Divide this by A. Divide this by A. Divide this by A. When you divide something, you just throw it in the denominator. A times 4, I think that can be a little bit cleaner, right? A times 4 is the same thing as 4A. And let's divide the other side. Well, dividing this by 4, maybe I should have done that up here. That's, if I would have divided by A at the first step like I should have here, dividing by 0 doesn't do anything. So we'll pretend like I divided by A at the very first step. That's what I should have done there. Okay, I think I'm ready to factor this. When I factor this, let's factor x squared. How does x squared break up? X's and x's, right? Now, do you remember who to look at next? It's not the second term, it's the first term. I'm sorry, it's the third term, right? How do you think that I should factor the third term? It's unlocked by looking at the top value. Look at the top value. How should we break up a b squared? B's. And how do you think we should factor a 4?
2.
2 and 2. That's correct. 2 and 2. How do you think we should I think that when I squared, I should have divided by a at the very beginning. If I were to divide by a at the very beginning and I would have squared that, that would have been a squared. A squared factors into a and a. That's nice. Look at the left-hand side. You know what the left-hand side now gives me is it gives me something squared. It gives me x plus b over 2a times x plus b over 2a squared. The right side, we'll get there. Now what? Now what should we do? Man, it really messed me up when I forgot to divide by a at the very beginning. Sorry, folks. I should have divided by a at the very beginning. Okay, now what? Remember what we do next is we get rid of the square. What should we do to get rid of the square? Square root. Square root both sides. The square root gets rid of the square. That's fun. Okay. And let's take a look at that right-hand side just for a second. That right-hand side, we got fractions. And we got fractions that are trying to add. When you add fractions, you need common denominators, right? So we need a common denominator. In order to get a common denominator, this fraction needs the 4. This fraction needs the a. So my common denominator here is going to be 4a. Both of these guys. So that c, he needed a 4, right?
No. B squared minus c over 4a.
What did I do? No, I messed myself up. Remember here, I should have divided by a at the very beginning, so this means an a squared here. So we actually need a 4a square. That means that this poor little fraction, he needs another a and he needs the 4. So the top needs another a and a 4 as well. He needs another a and a 4. So that c, he has the 4 now and he has an a. It looks like the second fraction, he's straight up. He's good. All right, that's good. Now I think we need
Aspirin.
an aspirin, and we need that left-hand side. The good news is that there's two more steps. Next step, get x by itself. Look at where x is. Tell me how to get it by itself. Subtract, right? So we subtract this minus b over 2a to the other side, okay? And then we got this guy, he's a positive square root of minus 4ac plus b squared. I think we can take the square root of 4a squared. The square root of 4 is 2, right? And the square root of a squared is just a. And now the math gods are smiling at us. We took the square root. They're smiling at us because we have a common denominator now. 2a and 2a is that common denominator. And now we'll never have to do this again because we have got x by itself. X value is equal to minus b. When we take a square root, you actually need to look at the positive and the negative version. So you got to look at the positive square root and the negative square root of b squared, I'm just going to write that in descending order, b squared minus 4ac and divide that by 2a. That's probably what some of you folks have been working on in the homework is that quadratic formula. That quadratic formula we've now derived. Okay? We've created it. We've derived the quadratic formula. That's why you don't let friends drink and drive, because that happens. All right, come on, that was a good one. All right. So that's the take home here. That's what needs to go on this board. Okay? Now we need to start perking back up. This is how we got the quadratic formula. Now we need to use it. That seems incredibly abstract, so now I need to help understand, okay? So let's kick back into gear. I know that wasn't meant for you to completely understand, but I wanted to at least to expose you to it, okay? This is me kicking back into gear, this is you kicking back into gear. So we're going to erase the board, and we want to understand what just happened, okay? But what you need to have in your notes from all that is you need to have that thing written down there. It might not make a whole lot of sense, but you need to get it there, and the next half hour or so, hopefully I can make it make sense. Okay? So I get the murmuring of that, that didn't make any sense. I don't get it. I'm confused. Yeah, that happens. That wasn't meant for, and frankly, it wasn't the best presentation that I ever done in my life. But the end result is we don't have to go through that process because we've got something now that we can use. What we can use now is we can use that quadratic equation whenever we have any quadratic, what makes a quadratic, x squared, quadratic trinomial. Any quadratic trinomial that looks like this. Something times x squared. That something will be an actual number. Plus something times x, that will be an actual number. Plus a constant, an actual number, equals 0. If this thing factors, factor it. If it doesn't factor, then we're going to take the numbers a, b, and c and plug them into the quadratic formula. If it doesn't factor, we're going to use that formula to help us solve. Okay? Let's take a look at an example. This one looks familiar, doesn't it? He looked familiar, and I went through a big rigmarole with this guy, and it was entertaining. But when I look at this quadratic trinomial, the first thing you need to do when solving polynomials is the same thing we did last time. You have to get it equal to 0. Okay, you guys got that? You got to get it equal to 0, and you need to make sure it's in the correct order. X squared, x constant. Because if it's in the correct order, then that tells you the value of A, B, and C. Now remember, we try to factor this, but it doesn't. It doesn't factor. But frankly, even if it did factor, we could still use this technique. Regardless of whether it factors or not, you can solve any quadratic using that formula. All you need to know is you need to know A, B, and C. What is A? It's the number in front of x squared. What's B? It's the number in front of x. What's C? It's the constant value. Okay? A, B, and C is not just the first, second, third. I need to say that again. A, B, and C is not just the first number, the second number, and the third number. A, B, and C is the number in front of x squared, that's A, the number in front of x, that's B, and C is the constant value. Okay, so in this case, the A value is the number in front of x squared. You see them? Squint your eyes. That's 1. B, the number in front of x. And C, the constant, 1. It has to be equal to 0. And it has to be in the correct order. If it's not equal to 0, get it equal to 0. Okay? Now we're good to go. This thing doesn't factor, but we can use the quadratic formula. From the quadratic formula, you need to commit it to memory, but remember on the midterm, you're going to have that cheat sheet. That needs to be on the cheat sheet, folks. Okay? Commit it to memory, but it needs to be on the cheat sheet just in case you forgot. Let's use that to help us find what x value makes this true. What x value makes this true? It's going to tell us. Look at the formula. Minus b plus or minus the square root of b squared minus 4 times a times c. Divide that. Division can happen, but that's happened in both terms. Division by 2. 2 divides into 4. 2 divides into 2. So what happened is we could physically divide by 2. Divide by 2 here, divide by 2 here. This leaves me with negative 2 plus 1 square root of 2 is just square root of 2. And likewise, over on the other end, division by 2 can happen there. Then let me finish the other. I don't know. Negative 2 minus square root of 3. So that division can happen because we simplified that square root. That's why simplifying the square root is important, because sometimes it allows division to happen. Sometimes it doesn't. But I think that was the same answer that we got earlier when we did the other technique. This works. Quadratic formula works with any quadratic trinomial. This is going to take practice. Okay. Everybody got what they need here? I don't want to start over there, actually. Everybody got what they need? Let's try again. Why are... I have that problem, too. Did I really say that? So, why are we doing the quadratic formula is because some quadratics don't factor. And we need a technique to find that x value. And if they don't factor, we shouldn't expect our x value to be cute. It's going to be a pretty nasty looking square root. So, and the nice thing is, you remember guess check? Like here, this quadratic trinomial requires us to do guess check. And when I asked the question, do you remember guess check? If your answer was no, I don't remember guess check, then I got good news for you. If you don't remember guess check, the quadratic trinomial will solve this without factoring. So even if this does factor, and I don't think it does, okay, chances are it doesn't because I just made it up and I can kind of see here that it doesn't factor. Even if it did factor and the factorization is difficult, you could still use this and get x, the x value you want. Okay? How do you use the quadratic formula is you need to make sure that the quadratic is set equal to 0. Check. And the quadratic is in the correct order. Is it in the correct order? Yes, x squared, x constant. Perfect. X squared, x constant. Next thing you do, if it's in the correct order and you want to use the quadratic formula, what should be your next step? A, B, and C. Find out what A, B, and C is. That's right. Yeah, I think somebody said plug in, and that's right, but I think first we need to know what to plug in. Maybe you can just visually see it, and that's okay. But I think it's good to take 5 extra seconds and just identify A as 2, C as 3, I'm sorry, b is 3, c is negative 4. That tells you what to plug in. Now we can find the x value that makes this thing true. Quadratic formula is going to get it for us. Minus b, this is what I do every time. I mean, I'm not doing this for dramatic effect. If I was going to solve this, I would go through and I would put parentheses every time I see a letter. B squared minus 4ac divided by 2a. I really recommend those parentheses. Just going through, wherever you see a letter, put parentheses. It keeps my negative straight. It just cuts down a lot of mistakes. And now I can plug in. I can plug in my b value. I can plug in my a value, my c value, my a value again down there at the bottom. And now I'm just ready to clean it up. Remember, when you clean it up, clean up the inside of the square root first. Okay? You do got to pay attention to this little guy. I don't think we've seen a case yet where we got minus and negative. But sometimes that happens when you have those back-to-back negatives. If you have back-to-back negatives, that first term ends up being positive. But that's not the case here. He's got straight up negative 3. It's not minus a negative or anything crazy like that. Straight up negative 3. We'll do the inside, square that. This is where you need to pay attention. Negative 4 times 2 times negative 4. Positive 32. I just multiply all three of those one straight shot. Negative 4 times 2 times negative 4. Okay? Negative 4 times 2 times negative 4. Positive 32. Good. And that's all over 4. Clean it up a little bit. That gives me negative 3 plus or minus the square root of 41. See if that square root can simplify. Go to the factor tree, square root of 41. I don't think you're going to get very far, right? 41 isn't divisible by anything other than itself and 1. So my two solutions, I got two solutions, two values of x. What's my first value of x? It's a fraction. Tell me the fraction. Negative 3 plus, that's good. Square root of 41 over 4. That's the first value. What is that? I don't know. It's something. Square root of 41 is about 6.5-ish, I guess. So if you want to do an approximation, you can. So that value is probably hovering around like 0. Yeah, 0-ish. But this is some value. I don't know exactly what the value is, but it's some value. Okay? What's the second solution? Yep, negative 3 minus that square root over 4. Okay? Can any division happen with these fractions? Can you divide that 4? Now, it has to divide into this and the number in front of the square root. It doesn't do either, right? That's it. That's the two solutions to the quadratic.
So that would be the answer?
Those two fractions are the answer.
Okay.
Just like if it did factor, the answer might be like 2 and negative 3, but these are kind of ugly looking fractions. Yeah?
When we write out our answer, do we have to write out the two separate fractions, or can we leave it as the negative 3 plus
Yeah,
4
good question.
minus?
For a midterm, the plus and minus is really good notation. I would actually like it. It's easy on the eyeball. So this would be perfect.
Okay.
In MyMathLab, however, you need to separate it out. In MyMathLab, you've got to get the fraction going. So you get the fraction, got to type this in, divided by 4, comma. In MyMathLab, you have to do this, comma, this.
So you're saying on the midterm we can just leave it like that?
Yes. I actually prefer it. It's really easy to read. Okay. That's good. Okay, I think that the good news is you folks know how to simplify square roots. Right? We talked about that last time. Yeah, Matt?
How do you write the square on MyMathLab?
It's an icon. So over here, where I don't know if you remember, but they have like little tools, and they have like a fraction toolbar. You know, like over here, there's icons. There's going to be an icon for that. There's an app for that. Okay, so, yeah. I want you to take a look at something else that creeps up. While I'm thinking, I want to remind you that Wednesday, I'm going to have a practice midterm for you folks. Okay, so be here Wednesday. We'll review for the midterm then. Thursday.
I gotta work Wednesday. It's not gonna work.
Half the task is just trying to translate what I say, huh? Okay. When I say Wednesday, I really mean Thursday. All right, here we go. There's something interesting that happens here. There's actually two things interesting. Let's solve, in other words, find the x value. Let's solve this guy. A couple of interesting things here, if we want to solve this. All right. When you look at that, I think that there's probably something automatic we should do.
Squares.
Sorry? Equals 0. Right. That's what we should do. If you have a quadratic, we do, get it equal to 0. I don't care if you're factoring. I don't care if you're using the quadratic formula. Either way, you've got to get it equal to 0. Okay? Regardless of what technique you use, it has to be equal to 0. That's an always statement. Get it equal to 0. All right, help me then. Add 64. Seems like this guy might factor. We'll take a look. Okay. GCF, anything divides to a 25 and a 64. Now, not a trinomial, right? Difference of squares. I agree it is a square. This breaks down to 5 and 5, x and x. This breaks down to 8 and 8, right? But listen, is it a difference of squares? It's not, right? So it doesn't factor. If this was a negative, if it was really a difference, then go for it. 5x plus 8, 5x minus 8, set them both equal to 0, you're on your way. Unfortunately, it's not a difference. It's a sum of squares. Sum of squares don't factor, okay? All right, if it doesn't factor, then how do we solve it? Well, we solve it using the quadratic formula, right? So let's see. This feels a little bit awkward because there's not 3 terms, there's 2 terms, right? That's okay.
So we're implying that b is 0?
Yeah, right. So the a is the value in front of x squared. That's 25. B is the value in front of x. We don't have an x term. That means the b value is 0. Because there's not an x term, remember, b is not the second value. B is the value in front of x. We don't have an x term. We have an x squared term. We do not have an x term. We have a constant term at 64. All right, now we're ready to go. Now we're ready to use our formula here. So here we go. The x value we want is minus b plus or minus the square root of b squared minus 4 times a times b. Okay? And we'll divide that by 2 times a. Minus b plus or minus the square root of b, 0, b squared minus 4 times a times c. We'll divide that by 2 times my a value. All right, here we go. My first term is nothing. I don't need to write my first term. So I still have a positive and negative version of this square root. 0 squared is 0. Let's put it there for dramatic effect right now. And now I'll multiply those 3 values. Negative 4 times 25 times 64. It would be a negative 640, isn't it? Got a 0. Yep, that's 100. 2 zeros, not 1. Okay, that's good. So 0 minus 6,400 divided by 50. All right, here we go. We're almost there. Plus or minus the square root of negative 6,400 divided by 50. Let's see if we can't simplify that square root. In your calculator, what I want you to do is I want you to try to find the square root of negative 6,400. See what happens. Don't be offended if it gives you a 4-letter word or if it starts smoking and hissing at you. That might happen, I'm just saying. Yeah, it gives you an error. Why do you reckon the calculator doesn't like the square root of negative 6,400?
This is a negative.
It's a negative. Remember what the square root asked. The square root of 4 asks what number squared gives you 4. That's why the answer is 2. What number squared gives you? What number squared gives you a negative, like a negative 4? Nothing. It doesn't exist. You might say, well, how about negative 2? Negative 2 squared is negative 2 times negative. That's a positive 4, right? You can't square something and get a negative. This does not exist. It's not a real number.
It's a line.
It's not a real number. Why? Because there's a negative on the inside the square root. It's an interesting choice of words, don't you think? That it says it's not a real number, almost implying that there's things out there that aren't real numbers. It's true. What we're going to do is we're going to see that a lot of times when we have a square root that has a negative on the inside, what we do with the negative on the inside is that's preventing us from moving on with the problem. So what we do with a negative, look over here on this whiteboard, please. I think this whiteboard should be dedicated to stuff that is important. And you need to know about the midterm, you need to know about the quadratic formula, and you also need to know this, that if you have a square root, if you have a square root that has a negative on the inside, the most generic case I can put up here is a negative 1. Just the most general case I can tell you about. What we do with that negative is we take care of it with this letter called I, and I represents an imaginary number that takes care of that negative. And now we have a positive inside the square root. So you might say, now wait a minute, you can't just wave your wand and pretend like, yeah, I kind of did. I waved my wand and said the negative on the inside is no longer there. And how I notated that I waved my wand and made the negative disappear is there's an I that comes on the outside. I is the square root of a negative value, the square of a negative 1. Okay, so in this case, what I'm going to do back yonder is I'm going to wave my magic wand and say, you know what? This actually is going to be plus or minus I. What does that I do? It magically takes care of the negative. Sometimes that happens, folks, when you got a negative on the inside of the square root. And now let's see if the square root of 6,400. They didn't like negative 6,400. See if your calculator likes positive 6,400. So here our solution is positive 80i. If you want to put that I in front of the 80, it's just not good notation. Divided by 50. And negative 80i divided by 50. And I think you folks know that those fractions can reduce, right? They can reduce to divide by 10. They can reduce down to 8/5. divide by 10 gives us 8/5 I, or -8/5 I. The only thing we did different was a negative inside the square root must be taken care of. Calculators don't like it. You can't take a negative square root. You cannot take a negative inside the square root. How do you take care of the negative inside the square root? Is with a I. The I stands for an imaginary number. It takes care of the negative inside the square root.
So is I be viewed as a -1?
The square root of -1.
Okay.
Yeah? Square root of -1. Okay, good. One more and we'll break, okay? One more and then we'll break.
You can read my folio writing, numbers, and look at your fingerprint.
Before we get to the last example for today, let's review some important facts. Some important facts are things that are nonlinear. That means they have exponents. They can be solved two ways. One, by factoring. Okay? How do you solve by factoring? You set it equal to 0, you factor, and then you set each factor equal to 0. Sometimes that's easy, but sometimes it doesn't factor, or it doesn't factor easily. If you have a polynomial, in particular a quadratic polynomial, then we can solve that using an alternative technique. The alternative technique is the quadratic formula. That guy. Even if it does factor, we could use this. But especially for quadratics that don't factor, we use the quadratic formula. For instance, this guy is quadratic. Last example for today. He's quadratic. He equals 0, so he's behaving himself nicely. If it didn't equal 0, get it equal to 0, get in the right order. But he behaves himself. He's in good shape. Try to factor. You're going to waste your time. Okay, this thing doesn't factor. If it doesn't factor, we use the quadratic formula. The quadratic formula requires us to know what A, B, and C are, so we should identify those. A is 1, 1x squared. B is -12. C is +61. A, B, and C will help us to create this quadratic formula that will tell us the value of x that makes this thing equal to 0. What value of x can you plug in that makes that 0? We're about to find out. Minus b plus or minus the square, I'm looking at the quadratic formula, minus b plus and minus the square root of b squared minus 4 times a times c. Divide that by 2 times a. Plugging the appropriate values into the appropriate slots and then simplifying it down. Okay, to simplify it down, I think the most important thing is inside the square root. But before we get to inside the square root, we can take care of this. Right? What's up with that first term? Positive 12, good. Positive 12. Plus and minus the square root, -12 squared. -12 times -12 is a positive 144. And then we'll multiply these three values. -4 times 1 times 61.
Yep.
-234.
44.
44. Okay? That's good. Now let's, oh goodness, let's see what we can do on the inside. We still got subtraction, right? So we got 12 plus and minus the square root of, that's going to be a -100 over 2. Anytime I see a negative on the inside that square root, I'm not going to stress out about it. when you see a negative on the inside of the square root, all that tells you to do is just pull out the I on the outside. Just take an I on the outside of that square root. I usually put it in front. And just continue as normal. That's going to take care of the negative on the inside of the square root. 12 plus and minus I square root of 100. I just took care of that negative. Just pulled out an I. That's the job of I. It's the square root of that negative, square root of a negative 1. Okay? And now continue. Let's see. The square root of 100. That's pretty clean, isn't it? The square root of 100 is 10. 12 plus and minus 10i. The square's gone. The square root of 100 is 10. Good old-fashioned 10 divided by 2. That I makes it so that we can't physically add or subtract these, but we can break it up into its two cases. Hey, maybe before we break it up into two cases, can we divide here, by the way? Can we divide?
Yes.
Yeah, I think we can, right?
6 and 5.
2 goes into 12, 6 into... So our two cases are going to be 6 plus 5i
And 6 minus.
and 6 minus 5i. There's my two solutions.
Gotta love that. So could you write down, say, 11 and 1i? 11
Mhm.
Okay.
Yeah. Yeah, I think the question was, if I understood correctly, is it okay to add these? And it's not. They're not like terms. The I actually is kind of
Okay.
variable-ish. Just like you can't add 6 plus 5x, you can't add 6 plus 5i. Okay? So that's interesting, and I think I have confidence in you folks that you can do this, but one thing I want to do is I want to maybe bring about a little bit more context of this whole idea of I. I promise I'll get you to a break at quarter after. Let me talk about why. You don't have to write it down. I just want to look at it. Okay? I just want to look and see. Hopefully this computer is working. I just want to look at y equals. Whenever y equals, you could have a t-chart and eventually have a graph. I want to show you what the graph of this guy looks like. I'm going to bring up my online graphing calculator. Online graphing calculators can be found at rentcalculator.com. That's the best online graphing calculator you'll find. Rentcalculators.com. I'll show you how to get there. I want to show you what's going on with that graph. Remember, we just...
So that's y equals x squared minus 12x plus 61.
Remember, we just took this and we solved it for x squared minus 12x plus 61 equals, not equals y, but we just got done doing equals
0.
And then we got something crazy that had I in it, right? Okay. Look what happens. Okay. Rentcalculators.com. It automatically defaults back to rentcalculators.org. Set the mood. Where we find our free calculator is 3 options down on the left is free online calculator. And in the middle of the page it says free online graphing calculator. Don't hide, don't be bashful. There he is. And then you can put in the equation that you want. The equation we just got done solving for is x squared minus 12x plus 61. So I'm going to do that. X squared minus 12x plus 61.
Oops.
And then I'm going to go ahead and graph it. Don't see it, so I'll zoom out. There he is. Okay? So you can see this guy's definitely nonlinear. He's kind of more of a curve to him, right? And what we just got done solving is we wanted to know, when does this guy have a y value? Remember, when does it have a y value of 0? When does it have a y value of 0? Look at the y value of 0. This is the y value of 20. This is the y value of 10. This is the y value of 0, right there. When does this graph have a y value of 0? Well, it never does. It never reaches the point at which it hits 0. That's why you see the imaginary number, right? It doesn't actually come down and hit the line at 0. It never does, okay? So we give it an imaginary solution. Well, I guess then the next question is, why do we bother with imaginary solutions if they don't really exist? That seems kind of crazy, right? Well, it does seem kind of crazy until you think about this. If we have to multiply imaginary numbers times themselves. It's kind of interesting, but that again was more for culture reasons than anything else. Okay, let's come back at, I didn't print off your in-class assignment, so if you could come back, let's come back in like 17 minutes, okay? So I need to run off your in-class assignment. In-class assignment